need a pro photographer.
Pro?
Okay. Take your hand off.
So this is it floating by itself.
Okay.
We had George in there for...
Hold on. Yeah, I need to get balance in here.
George. Put your head down there.
Put my head down there.
Turn around.
I want my head. I want my head near the.
Why? You're gonna go in the water anyway.
How is he?
Because we can grab his hand.
Head first or feet first?
Okay, here, grab a foot. Sam grab his arms. We'll grab his feet.
Yeah, Sam, grab his arms.
How does this work?
Yeah, just lower me into
Yeah.
that.
We would have to pick him up
yeah,
and put him in.
Some of you guys are gonna have to step into that. Yeah, yeah. And then lower me, like my whole body at the same time. Okay,
This is hard.
my head goes here. I mean, I guess. It doesn't matter.
Okay, give me your foot.
It'd be easier to go face first, I'm pretty sure.
Yeah, that's what I just said. Okay.
How?
Alright, so on our first attempt, we put George in the boat, and it worked for a while. And then our cameraman messed up the video and cut it out. So we're gonna try again here, but it's a little bit damaged from the first time, so we're gonna see how this goes. Alright, let's carry it down.
Been a long day without you, my friend, and I'll tell you all about it when I see you again. We've come a long way, from where we began.
You know, we started.
Oh, I'll tell you all about it when I see you again.
I'll tell you.
When I see you again.
Go.
We're out.
Oh my god. No. Okay.
Well, it seems that our boat sustained serious damage from the first attempt, and it can no longer support George's weight, as you can see here.
Because of retarded.
But I'd say it was a mild success. It floated for a while before it broke.
Myth confirmed.
You can
Myth
float a
confirmed.
person in an aluminum foil boat. Maybe if we had someone slightly lighter.
Take that, Mom.
I don't know, if we revise the design, you might be able to get it.
But in conclusion, you can make a life-size aluminum foil boat. It's just very difficult, and you might drown. But
Yeah.
there you go. That's our boat.
There is our boat.
That's
what's left of our boat.
Alright, so in this experiment we had a boat that was about 72 inches by 7 inches by 36 inches, which is about 18,144 cubic inches. And if you convert that to cubic centimeters, you end up with 297,326 centimeters cubed, you know, and then you have 1,000 centimeters cubed in a liter, so it's 297.3 liters approximately. That's the volume that the boat would hold. And since the buoyant force is the mass of the fluid displaced times gravity, so 297.3 liters, because it's about 1 kilogram per liter, times 9.8 newtons per kilogram, which is the same as meters per second squared, and you'll end up with 2,910.6 newtons. And now if we consider the weight of George and the weight of the boat, which we originally had in pounds, so I converted it to newtons, which is about 654.35 newtons total. So in this great diagram here, we have the weight pointing downwards and the weight point, or the force downwards, which is the boat's weight plus George's weight, and then the buoyant force pushing upwards, you can notice that 2,910.6 is definitely greater than 654.35, so George should be able to float in the water. However, due to the faulty design of the boat, being aluminum foil isn't going to make a perfect watertight seal, we end up with, water coming in, and then that water adds weight pushing downwards. And then more water comes in, and then George is underwater, and he starts trying to get out of the water, but he sort of doesn't get out of the water, so he eventually gets out. Don't worry, he didn't drown. He's still here.
Face that way.
Is that how you're supposed to do it?
What do you mean to? You press the trigger by yourself.